It is with great pleasure that I give you two very dear friends of mine, Unger and Jake Carroll, doing our last presentation on strange things that lurk in your supercomputer cloud. I excluded the parentheses.
It's fine, man. It's
fine. Give them a welcome applause, guys.
Good afternoon. So we're going to be talking about a couple of different scenarios, outsourced cloud in particular for myself, where we're talking about lessons that we've learned and some of the perceptions of the technical staff versus the organizational realities that bring us towards the cloud, and also the realities that the service delivery then goes towards.
Yeah, so I guess the other side of it, which is my side, is I'm going to talk a little bit about in-house clouds and some of the implications of them, freedom and control in the security domain, industry-specific security posture in the world that I come from. I'm not a security guy, I'm not a security researcher. I work in supercomputing and research computing. This is a little bit strange in that regard. The performance expectations around why we do the things we do, why we bend the rules with security a little bit, and some of the other oddities which we come across. And I'm going to give you an example of something strange that happened with a supercomputer recently from a security incident perspective that took us by surprise and is quite complicated. So,
if you fall off the stage, I'm going to laugh.
It'll be fine.
Okay.
It'll be good. They'll get a laugh out of it. You need that in the afternoon, right?
All right. Yeah. We all know how IT services are built. You can have good, cheap, or fast. And of course, that assumes that there's somebody there that's going to build something good, and you have resources that can, in theory, be fast. Broadly speaking, cloud is a disruptor, and no surprises there, but it changes the traditional. It isn't a drop-in replacement. Everybody's probably seen that graphic. I've seen it on a few laptops around the place. So there is no cloud. It's only somebody else's computer. And with the move towards outsourcing sort of being encompassed into the term cloud, it's also other people's stuff. It comes in three broad flavors. You've got your infrastructure, service, and platform as a cloud. Not in that order, but nevertheless. And they may be public, private, hybrid, and then different vendors slap different coats of paint on there. According to Gartner, you have greater cost agility, especially with infrastructure as a cloud, as a service, sorry. You have increased retained cache. You have reduced opportunity costs because you have more cash on hand. But on the con side, you have higher subscription fees. For starters, you have subscription fees. And especially with software as a service, you have decreased cost agility and much greater switching costs. This may, of course, vary by your organization. So if you're greenfield setup, it's going to be very different experience than if you're an established company organization with established services moving to the cloud. And over the life of the cloud implementation, any decisions that you make will feed back into your decisions, etc. So it's a loop. So avoiding the rant about ITIL and value, the conspiracy is that companies are moving to the cloud to save on staff. But the reality is that the vision is to reduce risk exposure. We want to reduce the complexity of maintaining services. And at the same time, improve the user experience by leveraging the vendor expertise and their proximity to the service. They can deliver better because they're closer. At the same time, you want to reduce cost, and this is something that keeps coming up, because you can just turn off stuff you don't want to use anymore, but the reality of that is probably a little bit different. Software as a service, platform, and infrastructure meet that vision in different ways. So you get your software, which is just software in the cloud. Platform as a service is the software plus the specialist knowledge, minus the hardware in your data centers. And IaaS is just do-it-yourself and offsite. And it comes with lots of toys that don't necessarily make sense at the time. So you have reduced control and less transparency over your status. Usually I find out from my users that Office 365 is down or not logging in. And then sometime later, Microsoft announces this too. So we know they're right, which we already knew at that stage. Dynamic scaling is complex, and it's potentially difficult to validate. And while you can save money, you have to do it for the right services. You can reduce risk but any service outage continues to be your problem. It doesn't matter what the cloud vendor tells you. And any breaches are also your problem. And at the same time, you might be introducing new risks, and you probably need to mitigate them, and they may be greater than what you had to start with. Single vendor stacks, so platform as a service and software as a service help with that setup, but many of the exclusions to your service delivery are usually implied. They're not up front and center. You sort of discover them. Your flexibility is impacted, and you introduce new constraints, which may be layered. So you're usually constrained to the vendor that you've just chosen by virtue of the definition. The support center and time zones might be not moving with the sun, and outage windows might be forced upon you based on where they are based. So then your user support might suffer from that because they're only available during UK times, as we've experienced.
Follow the sun, or not so much. Yeah.
It's getting better. And for infrastructure and cloud-hosted VMs especially, there are architecture-specific service and use cases that change the risk, but they require different skill sets. So you may not have the people on staff just yet. And also, one big thing that we found is that the risk reduction is sort of sold as a feature, but it raises your entry price. Multi-vendors become more interesting. They've got all the problems I just elaborated, but you've got multiple vendors. And then you have gaps between the service arrangements. So who's doing the operating system patching for an infrastructure service? Who just clicked the thing out of your 4 vendors that are supporting your service? And if you have a breach, who's going to report that in compliance with the local laws? I mean, if you're here, and that's not entirely true because I've met some international people, but if you're here, odds are you're subject to Australian laws. So is your cloud vendor? So countering that conspiracy from earlier about reducing staff costs by getting rid of staff, if you have less and or lower skill staff, you have re-engineered your services and advertising your outage windows with far too much detail, which happens, and your data is hosted on another organization's platform, then you're increasing the attack surface, your susceptibility to social engineering, and service complexity. In other words, risk. Generally speaking, increasing risk is not the strategic goal of any organization, so the conspiracy really doesn't hold up.
Come on, live a little. This will be fine. All right, cool. So we're going to kind of flip a little here and change the gears. There's all these concerns about different mechanisms in outsourcing capability, but in this kind of, I call it a fog of technology war, there's some less obvious problems, and I kind of live those every day. So collectively and unintentionally, you can do a lot of harm with a really big network pipe connected to a supercomputer. I happen to have one of those, several in fact, and my wonderful organisation has enabled me to do those things. But this kind of drifts into that weird kind of territory where I want to get to, and that is the problem with these in-house capabilities we have and the attack surfaces which they create and the risks which they create. And we're going to dig into that a little bit because these problems are less obvious. So, we do those normal, boring things inside supercomputing. We do the boring, well, you all know what AF is, I think. But anyway, yeah, we do the boring things. We have our fail-to-bans. We use our port hardening mechanisms. We firewall things. We have border edge default deny permissions. We containerize things with singularity if we worry about them. Does anyone know what singularity is in the room? Okay, one person, cool. So think of it like Docker for grown-ups. So yeah, see what I did there? That was intentionally gamey. So yeah, log watch, log analysis. We use elk and tripwire and all that. So all those normal things that you would expect from any shop doing anything in normal security, we do those things too. But then things get a little bit weird. So supercomputing people are special and sensitive. We're an odd bunch. there's at least one individual in the room who works in supercomputing like I do, and he knows what I mean. So, we have all these codes and things, and the way our machines communicate with each other are a little bit strange. So much so the fact that when our file systems talk between nodes, we're actually privileged executing memory pieces between nodes and processes as if they were running as root. Okay, we do strange things, and to a normal security person, it's terrifying. It's a horrible thing. What were you thinking? You people are monsters. So just to see what it looks like, this is the summary of a basic supercomputer. You've got a massive 100 gig pipe there. You might have a head node which is really nicely locked down, but then behind all that, you've got all these cluster nodes which are 100 gig RDMA connected, and they're sharing memory and things all the time and processes as if they were running as root. Okay, privilege execution takes place in these environments all the time. That makes people shake. I've actually had audit type people come to me and say, well, how does this work? Is this even okay? How can you even get away with this? I'm like, well, this is how a supercomputer works. So the untenability of inspection and observation is an important thing here. So people will say, oh, you just need to look at things more carefully. Well, not quite. People say, won't somebody think of the children? This aligns with the requirements of how supercomputing works. It's a function of performance and the way we actually do business and what we're looking for. Time to discovery is what we care about, not keeping things locked down tightly. Okay? It doesn't mean we don't find interesting things that happen occasionally because we can't observe certain things because of the speed we work at. Think of multi terabytes of data flying at you every second, and then try and observe that every second and analyze that every second in some meaningful way. This is why it's hard, okay? So, the nature of the way things fly through our networks looks very different to the way they fly through your networks as a TCP stack. Things aren't the same, okay? The problem with 100 gig flows, of course, as we're grappling with in our organization at the moment, is actually keeping an eye on them. It's sort of hard, okay? So, kind of moving along, the things you can think, I'll get into the crux of this and some of the strange things we've seen happen. I'll be a little bit vague because I can't say too much, more vague than I am, right? I'm always vague, right?
Always vague.
So, does anyone know what a generative adversarial network is? Has anyone heard of a GAN? Awesome. So, one person, that's awesome. I actually meant that, thank you. I'm glad you know it. Wasn't being facetious. So this is a form of machine learning technique that's currently being used kind of at the top of the food chain for a mechanism that's used for learning by itself using unsupervised learning techniques. And there's a lot to that which I won't unpack here. But we've actually seen this stuff in action. So this is what was known as a proposed model of an IDS GAN, right? What does it mean? In short, people using mechanisms to guess, intrude, damage, and exploit using machine learning techniques of a very, very complicated nature, using generative adversarial networks. It effectively means that you are not using supervised labeling techniques in your AI or your ML workload for things to guess. So it is no longer about brute force. It has become about the algorithm learning by itself to get done what it needs to get done. Okay, and this stuff's happening in real life now. How do I know? We've seen it happen. And yes, the box is supposed to be black. We found this odd process on a login node a little while ago. I've tried to get rid of anything in the text which would harm the innocent and stupid. So this is actually a process that was running a 0MQ batch. And we didn't know why 0MQ would be running on the head node. What was it transporting? What was it doing? Turns out, way down the bottom, we could actually see a private directory of an Anaconda 3 install, a private Python install in a home directory, and we thought, well, what's that doing there? No one uses private Anaconda 3 on this system. It's preloaded. We have it all in modules. So that was weird, and we started digging. And I thought, what's the deal with that? This thing's got a site-wide Anaconda 3. Why is it doing that? What's this person doing? Went and had a closer look. Oh, look at that, my old friend Jupyter Notebooks. So what's the Jupyter Notebook doing? Why is it launching like that? What's it doing on that port? Well, what's actually happening here? So we then dug a little bit more. And if top output showed some strange things, something was ending up in Slovenia somewhere. Why were things being sent to Slovenia, we wondered. this alone isn't enough to kind of go, oh, this is really weird. Running that much CPU time and memory on a head node, though, is kind of odd. And why would it be communicating with Slovenia when it is an organizational, internal super, which doesn't, to the best of our knowledge, have anything to do with Slovenia? So we started digging, and it got a little bit societal at that point. Keeping in mind, again, not a security researcher, just a person that has to live and deal and breathe with these things. So what was the user actually doing? Well, it turns out a GAN was actually using a looping mechanism to take an increasingly educated set of guesses, targeting a financial institution. And it was an IDS on the other side of the world of a financial institution. The GAN's intentions were hidden from view, and they were obfuscated inside that black box. We couldn't see that black box, and that was the discriminator of this AI mechanism or this loop. So was the user doing anything wrong? No, the user was actually innocent in this, and we had to get to the bottom of why the user was running this code. As far as the user was concerned, they were getting the correct outputs, okay, out of this piece of code that came from GitHub. So they were innocent victims, right? The code had been passed around 4 or 5 very, very large research institutional labs around the world, one from Europe, one from Japan, one from Hong Kong, and one from Australia. It had been tampered with in a really sophisticated way to the point where we couldn't tell the difference between the binary. And the user got their scientific outputs. Everything looked sweet, so they were getting what they needed. But the payload was attacking an organization in an extremely sophisticated way, right? And they were using GPUs to do it, right? So the implication for this stuff is that it's really hard to detect malicious code for us, right? It's really, really hard. We didn't know what was happening until after the fact, of course. We couldn't see anything because the user was getting their outputs. And an unusual bit of traffic, it's not always enough to put your hands in the air. I don't come from the space that a lot of you come from, and you have probably very advanced techniques to look at traffic patterns and whatnot all the time. But when you see something pop up and maybe send a text file occasionally or something over an email transport like that, no one would think anything of it. It could be somebody emailing their colleague in some automated way. We don't know. So, you know, the way to get to the bottom of these things was social means. We had to walk around and talk to people and ask questions about what was going on here, and then track that back to another lab, and then track it back to another lab, and track it back to another lab until we got an answer about where this thing had been tampered with along the line. So heuristics tend to fail us here. You get to look, but you need to look very deep. So, you know, this is just a little bit of an example about where our fail to ban outputs got and some of the IP blocks that started spewing. My sysadmin back home was kind of, off his tree that day. So how does this end, right? How does it end? Researchers don't really, you know, as research, we don't have the resources to be security intensive. It's not what we are, okay? We go fast, we break things, we melt worlds, and we discover things and we cure cancer, right? Things are going to be better for everybody one day because of the things we try to achieve. It doesn't have any interest or appetite in security either. These systems exist for research. I guess a concluding possibility, if you want to call it that, is, you know, we throw that financial attack surface and that risk over the edge where we do wild and crazy things, and we put it in a public cloud and go, yeah, you can do your stuff out there. You know, we want to burn dangerous cycles and make a mess of the place. We'll do it on your own dime. Do it out there. It might be better out there. Do we want to make a mess? Maybe we can do it out there. Maybe we can pen it in the public cloud in a safer way. It won't harm us. It will harm only itself. Okay? So is the public cloud a risk mitigation mechanism, or is it a risk creation mechanism, or is it both? I think it could be both, right?
All right, so how you choose your cloud and where you're going to run things really ends up depending on a couple of factors. The one factor, start with, the big one that we tend not to say is all important, but is money. So if you're a capital expenditure focused organization, then you have to make choices. If you're a greenfield setup and you don't have any hardware purchased, you don't have a data center, then maybe going into the cloud makes a lot of sense, versus if you're an established organization that has all of those things. And at best, you're not buying a set of new hardware, for example. There's a question about operational expenditure. If you're a cost recovery organization versus a non-cost recovery, makes a big difference. If you're Netflix, you charge your people to use the cloud. Whatever they need, you charge them. It's built in.
Better economists than we do, right? So, yeah, it's
staff costs. Do your staff costs change? Well, the expertise for running services on infrastructure as a service don't really change as far as I can tell. You have different knowledge, but your staff numbers don't change around that. You need to maintain less hardware and plant at your site. there's a potential saving there. But cloud leverage solutions might require more time to test because you now have more toys to play with. You have the ability to design better services, and all of this takes time, of course. The solution you end up may well be much, much, much superior to what you can do in-house in a single data center. And lastly, your support staff counts may increase. So especially with platform and software as a service, if you have an email solution and you're moving to Office 365, your users are getting a lot more toys. So again, you have probably much more support requirements around that. And finally, on the point of cost savings, even if you're saving those costs on staff, do you end up giving that money away to your professional services people or your hosting organization? Other things, workflow and flexibility for users may well improve, but you really have to be selective about which cloud services you use. So if you go blindly cloud first, you're probably going to have an issue. It's a buzzword we found the other day. Don't know, doesn't matter. Yeah. Your changes to staff, well, a change is not a saving. And lastly, the workflow and flexibility of the organization depend on the industry, the use case, the organizational maturity, and the number of services. Flexibility adds to your complexity issues, which of course is an issue to security setups, but at the same time, you may gain resilience improvements.
So on the other side of things, it depends on the purpose. So this is kind of where things get a little bit, I guess, ideological. The context in which you launch into cloud computing kind of matters. Seems to be a lot of ideology out there rather than quantitative and qualitative analysis in the way things are being done in this sector. And I say this as a comment to the sector in general, not just in security, and I think the sector should listen. I know you all understand these things. There are entities in the sector that don't, and they need to take note. Rather than this ideology of cloud, centric first, focused, whatever, it's about appropriate use of technology, and you can get yourself into a lot of trouble if you're not thinking a little bit more carefully and a little more credibly. What Gartner teach you and what those IDC guys teach you down between those lines is not necessarily the truth, and we should wake up, right? Depending on the actual strategic research or enterprise drivers which you've got going, things could look very different for each and every organisation. All I can say is people need to wake up. Governance, although cumbersome, it needs to be applied to this cloud bloat thing. And there's rogue instances of this that are everywhere. So it's not just infrastructure which spans and makes a mess. Clouds do it too. There are people whose intelligence in this room I respect quite a bit who have ranted to me before about how we're just doing exactly the same things we always did in clouds, but we used to do it in infrastructure, now we do it in clouds. We make a mess in clouds instead of in our data centers. So it's something to really think about and be mindful of.
But it's not all bad. So you have security services which supplement and leverage cloud characteristics. So we've got our cold storage scenarios where we ensure that your data is far, far away, and if you arrange it with your insurance in advance, that when you have to activate that recall, you don't pay for the data transfer or the insurance has to cover it, then that's quite a good solution. Backup and disaster recovery as a service can get you out of your specialized equipment, like tape drives. He's got more than me, but for me that's very specialized, and I seldom, try to interact with them. And cloud also encourages good continuity design. You have physical differentiation, where you can design and architect setups that enable continuity. You can reveal real issues by actually testing your setup. And that testing you can do by cloning your actual live stuff into another availability zone, another country, and working on the real thing. Probably not in production, but nevertheless. And then you have cloud-native services, so things that are born off the cloud. Email comes to mind. It's always been in the cloud. Office 365 is not a gigantic revelation. Web hosting, cloud storage, same thing. You have services that benefit from cloud characteristics, like your monitoring setups, which are remote and looking in, probably can scale much better to your data influx over time. Backup, again, not local. Doesn't matter if your building burns down. HSM archives for very cold storage, we already touched on. Malware scanning, sandboxing, doesn't hit your infrastructure. It gets dealt with before it gets there. Cloud for cloud systems, so password saves, device management, MDM type things, and your niche scenarios, so your small tasks, Flow, SurveyMonkey, large, complex, things that enable you to do your stuff but aren't part of your business. So that database for your inventory system that really you just have to have for legislative reasons. And yes, diverse geolocation services can also save you a lot of money depending on what business you're in. It really depends what your organization wants to be. So in conclusion, on the top, for a cloud service that can change the risk profile of services, the skills and duties of your staff, and save or cost money. And on the other side, it's all dependent on the organization, each specific service, the service requirements, the interactions with other services, and the resultant architecture. One or two things remain for sure. Each influences the other. It's an iterative process. As your solution lives, things will feed into each other and then feed back. And lastly,
strange things lurk in those clouds.
yes.
So,
So
yep. So questions, happy to take them. Thank you.
Thanks very much, guys. So does anyone have any questions at all? If you have any questions on high-performance computing, you have probably a world expert at your disposal right now on machine learning AI.
Yeah, particularly in relation to, I guess, security or the things we've seen. If you're interested, yeah, can absolutely talk to that.
All right, well, we've got 10 minutes to go. Well, extra 10 minutes then for afternoon break. And then we have the speed debate commencing from 40 minutes from now, shall we just say. Enjoy. Thanks very much.